you're going to see a discrepancy between what your notes are labeled as well as what the homework is labeled and the Schoology. So as I've said before, we are skipping units 11 and 12. I came up with that after the fact that I moved, that I printed off your notes. So that it is what it is. Moving on. So we are going to move into Pythagorean theorem. And Pythagorean's theorem states that a squared plus b squared is equal to c squared. So Pythagorean's theorem says a squared plus b squared is c squared. So what you need to know is what is a, what is b, what is c, what's the big deal about a squared and b squared. And I think if you had me last year, you had a right triangle unit. You dealt with Pythagorean and you also dealt with trig. So it's very similar. It's amazing critical thinking skills. What you need to know though, make your right angle here, that A and B will always create the right triangle. So, or the right angle. So A is called a leg and B is also called a leg. The legs are what create the right angle. And it's very important to know that. And C is what we call the hypotenuse. So where's my little thing? Here it is. I gotta minimize this. So C is the hypotenuse. The hypotenuse. C is always the longest dimension, and it's always opposite on the other side of the right angle. So I want you to cloud or highlight hypotenuse. It's a very important characteristic of any right triangle. And the hypotenuse is always opposite of the right angle. So your goal, usually what I always tell my 7th and 8th graders, find your right angle and then your hypotenuse. That's how you should always look. So find your right angle and then go to the opposite side. And it's also always the longest segment, the biggest, the longest. Okay? It's not always nice like that. The hypotenuse and the legs can always be rotated around. Your goal is to be able to tell what's what. So I want you to tell me if what I point at is a leg, a hypotenuse, or a hypotenuse. You only have 2 parts. Legs are the ones that make the right angle. So your eye should always be on the hunt for your right angle. Okay, so what is this dimension? Is that a leg or hypotenuse? Leg. Yep. Okay, what is, hold on. Let me rotate again. Rotate it. Okay, what's this dimension right here? Pretend that it lined up. What's that dimension? Hypotenuse. Hypotenuse, because your eye should be like, oh, there's my right angle, if it worked. And the hypotenuse is always the longest and opposite of the right angle. Let me do it again. Look at that. You can't keep up with that. Oh, okay, what's this right here? On the bottom. The leg is on the bottom, yeah? So, you have 2 learning targets today. Learning target number 1 is that I will give you dimensions, and then you're going to tell me if you can make a right triangle or not. And learning target number 2 is using Pythagorean's theorem to solve. Okay, so I need to be able to zoom here. Okay, so the first thing that we want to know is if I give you dimensions, like if I have the dimensions 3, 4, and 5, can I create a right triangle with them dimensions? 3 units, 4 units, 5 units. If you can create a right triangle, then you must be able to satisfy Pythagorean's theorem. Which, by the way, I forgot to tell you, is some random Greek genius who, his name is Pythagoras, and he lived way back in, I don't remember his actual dates. But for some reason, he would look at these right triangles and watch, I'm going to make the visual, do not try. And he was like, anytime there's a right triangle, I wonder if I turned this into a square, and if I turned this into a square, and add them together. Why he wanted to do that, no idea, but the math world thinks him. And then he's like, I wonder if there's a relationship for when I do the hypotenuse square. And sure enough, he found out that any time, with any size triangle he made, if he made both sides, the legs, into a square and added them together, it would always be equal to that hypotenuse square. No idea what inspired him to think of that. In math, to become famous for, to actually get your own equation, you have to actually prove it, and the proof basis is intense. Okay, so here I go. 3, 4, and 5. My first idea is to find my hypotenuse, which is my longest measure. So my hypotenuse here is at 5 pi. It's the longest measure. So you should have legs squared plus legs squared equals hypotenuse squared. So I should see, does 3 squared plus 4 squared equal 5 squared? And then I'm just going to plug that in. So I'm going to go 3 squared plus 5 squared. And that gives me, did I do a good job? 30, I didn't do it. 3 squared plus 4 squared, silly me. 3 squared plus 4 squared, enter, is 25. And then I'm going to do 5 squared. That is also 25. So yeah, I can make a right triangle with the dimensions 3, 4, and 5. And then you can just show 25 equals 25. So yes, this would be a right triangle. So you could have 3, 4, 5. It would look something like that. Okay? And it doesn't matter where you put the 4 and 3. Because addition is commutative, you can flip. Next one, can I make a right triangle with the dimensions 1, 7, and 9? Well, according to Pythagoras, I sure can if it satisfies that equation. So I need to identify my hypotenuse, so that would be 9. Call it C, call it H, I don't care. Call it X. A variable is a variable. And then that's my longest dimension. So I should have legs squared plus legs squared equals hypotenuse squared. So 1 squared plus 7 squared, does that equal 9 squared? And please don't be impulsive. Always just double check. 1 squared plus 7 squared is 50. 9 squared is 81. No, you cannot make a right triangle with those dimensions. What did we get? 50 does not equal 81. But you can still make a triangle. It would just be acute or obtuse. Because you could make, I think it would be more obtuse. You would have 1, 7, 9. It'd be something like that. It's still a triangle. You can make a triangle with any dimension. It's just to be a right triangle, it has to satisfy Pythagorean. So this would be obtuse. All right, learning target number 2, last one for today. We're going to solve for missing side lengths. What you need to know is hypotenuse is always opposite of the right angle. So now you're going to assume that all of your triangles are right. That's what, oh no. You're going to assume that all of your triangles are right. And I'm going to use Pythagorean theorem. So I'm trying to, here, a squared plus b squared equals c squared. C is a hypotenuse, which means it's the one that doesn't make the right angle. Watch how I'm going to do this. Okay. I'm going to use Pythagorean theorem. And I like to just highlight the ones that make the right angle. Those are my legs. So now I'm going to say, okay, I have 2 squared plus 4 squared, and that needs to equal x squared, which is c. Again, it doesn't matter, or h, whatever you want. And then I'm going to just punch that in. 2 squared plus 4 squared is 20. So 20 is equal to x squared. And then I still don't know. I have to do algebra. So what's the inverse of squaring? Square root. And we did that with working backwards with circles, if you remember right. So yeah, so x is the square root of 20. And I think that you'll want to round to the nearest tenth today. Oh, look at my calculator. It's like, hey, let's be fancy. And I'm like, what? I'm not going to do that. And then you just hit that arrow button. So 4.5. So 4.5 is what x would equal. I told Schoology round to the nearest 10 or whole, whatever you want. Okay, next one. What I like to do is highlight the one, what makes the right angle. So here and here, those are my right angles. So it looks like I'm missing a leg on this one. I need to find a leg. So you do a little bit different algebra. I don't care if you make the XA or the XB, doesn't matter. I usually like my variable first, so I'm just going to go x squared plus 4 squared equals 36 squared. And then I'm going to evaluate I know 4 squared by heart, but just showing you how I'm doing it. And then 36 squared is 1296. So here I can't just add them because I can't add 4 squared and x squared. Okay, do you see that? So now what I'm going to do is say x squared plus 16 equals, was it 1296? Yeah. Okay, 1296. So now I can't add, so I need to do the opposite. Subtract. So I'm going to subtract from both sides. And I get x squared equals, and that would be 1280. 1280. And then you got to get rid of square root. To get rid of square, use square root. So x is the square root of 1280. And again, what I would do is subtract that from the 16. And then now I'm going to square root 1280. It's going to be 35.8. 35.8. X equals 35.8. Hey, here's what I need you guys to know. Because you guys, I gave you a really good assignment today. By really good, I'm making your brain think. You are not doing the same assignment as others. So what I want you to do not put that away. Do not put it away. Okay. I want you, do you have room on the left-hand side? Heck yeah, you do. Yeah, you do. Yeah, you do. Okay, just stop. An equilateral triangle. Equilateral triangle has side lengths of something. What should I say? What should I?
42 and 74.
No, equilateral. 12. What is the height of the triangle? Okay, write this down so you can see how we do it. So, and I'll reread it. An equilateral triangle has side lengths of 12. What is the height of the triangle? Equilateral triangle has side lengths of 12. What is the height? Jason?
Wouldn't it just be 12?
No, sure wouldn't. Because height has to stand straight and tall, if you remember. When we did our geometry unit, when we had like base times height divided by 2 for a triangle, it has to be perpendicular. So if you have an equilateral triangle and everything is 12, well, there is nothing that's standing straight. So you got to find your straight. So watch what I'm going to do. I'm going to do a drop down. And this is going to be H. So that is the height. The height, look at me please. The height is straight. It's perpendicular to the base. Now what I really did, this is called a perpendicular, it's angle, but it's called a perpendicular bisector. Anytime you have an equilateral triangle, and if you were to do a drop down from the top vertex, it halves this. Do you see? So this equals this. You just divided it into 2. So now what I have is you can do one of 2 triangles. Do you see a right angle? So now I have a triangle on that second half. This triangle would not be 12, it would be 6, because I just broke that into halves. So now I have my right angle here, and anytime that I do Pythagoreans, I know that I either add, square and add them, or square and subtract them. And when you're missing something that makes the right angle, you always subtract. So this one, I don't know the one that makes, I don't know the length. So you can say h squared plus 12 squared equals 12 squared. Yes, thank you, because I was going to say, oh no, this is going to turn to 0, 6 squared. So then h squared plus 36 equals 144. And then I'm going to go 144 take away 36. 144 take away 36 is 108. So h squared is 108, take away 36. H squared is 108, and then square root it. And it's not going to be perfect, you're going to go around it. It's an irrational number. But I need you to know you have a couple like this today in your homework where they're going to say it's either an isosceles triangle. An isosceles triangle means two sides are equal. So it would look like this. An isosceles triangle means these two will equal each other. Okay? An equilateral means all sides are equal. You do not have a right triangle. You have to drop down, and then you made two of them. So just pick one to analyze. Okay? All right. That's your 2 learning targets.